So we have measures of central tendency, which were the mean, the median, and the mode, which is telling us where the middle of the data is, right, the average. And we have measures of dispersion. And the one we've looked at so far is the range, right, which simply tells us, what's the difference between the highest and the lowest? What's that number? A better measure of dispersion is the standard deviation. So the standard deviation of a set of data is a measure of how far the data spreads away or disperses from the mean. It's a statistic that is used throughout the world when data sets are compared. Okay? So it's going to come up over the rest of the lessons in this unit. Okay? So it's very important to get an understanding of it. So here's how it's calculated, right? Which is a little tedious, and our calculator will do it for us, but we're going to do one by hand, okay, just to sort of see how is this thing calculated. So I'm going to give you some numbers. So the mean of this set of data is 78. So the first thing you would have to do is figure out the mean, okay? But I have pre-done that for you. So mean is 78. Now, what we want is the deviation, and the deviation is how far is each of the group scores, how far is the x value from the mean, which is denoted with the x bar. So what you do is you take the x, you go 94 minus 78, which is 16. You go 56 minus 78, which is negative 22. You go 89 minus 78, which is 11. 67 minus 78, which is negative 11, and 84 minus 78, which is 6. So we now have how far each of our observations, each of our scores is from the mean. Now the problem with that is that some of them are positive and some of them are negative, right? So if we just added them up, we could end up with a 0, and that really wouldn't be a big measure of the dispersion. So to make them positive, we square each of them. So 16 squared is 256. Negative 22 becomes positive 484. 11 squared is 121. Negative 11 squared is 121. And 6 squared is 36. Okay, now you're not going to have to do this by hand, right? Your calculator will do this for you. But we're just going to see one or two of these where we actually calculate them by hand, okay? Just so you get an appreciation for where does this number come from. Okay, then what we do is we add up the sum of all of the squares of the deviation. Okay, so we add those all up, we get 1018. Bless you. And then what we do is we take the average of that, right? So we want the average of all of the squares of the deviations. So this would be 1018. Divided by 5, because there's 5 scores, which is 203.6. And then the actual standard deviation itself, because we squared all the numbers, we have to unsquare them, right? So we take the square root of the sum of the average of the sum of the deviations, right? So it's the square root of 203.6. which is equal to 14.27. Okay, now the standard deviation is denoted by a lowercase sigma. You're going to see that in your calculator. Okay, so you'll see a little sigma x, right? And that's what we're looking at. All right, so I'll leave that there for a moment. You can copy it down. Brian, you can copy it down.
I can't see that part on my glasses.
Oh, you can sit up here.
That's long.
Mm-hmm.
I'll be upstairs.
Morning. Where did you get this?
This?
Just have like a big one.
Took the sum divided by the number of them. So it's the average of the sum of the squares of the deviations, right?
I thought the 3 was a 1.
And then we take the square root of that because we squared everything. Okay, we got another set of scores here, right? So we've got group A, we got group B. We're going to do the same calculations. The mean here is 78. Okay? Now, if we kind of look at the scores themselves, we can see that the first group is a little more spread out, right? It's got a higher high mark, it's got a lower low mark, and these guys are all fairly close to the mean, right? So when we take their deviations, we got 5, -2, -2, 3, and -4, we can see their deviations aren't that much, right? Now, to get rid of the negatives, right? Because we're really interested in how much does it deviate from the mean? And we don't want to add these guys up because we got positives and negatives, so we square all of these guys. 25, 4, 4, 9, and 16. Then we add up all of those. Okay, so we add up 25 plus 4 plus 4 plus 9 plus 16. That's 58. We take the average of that, so it's 58 divided by 5, which is 11.6. And then finally we square root, right? Because we've been squaring them all, so we have to unsquare. So we take the square root of that, and we get the standard deviation, which is 3.4. So if we're comparing these two groups, right, if we want to compare these two groups, leave that there, let you copy it out. One of the questions we're going to ask when we compare the two groups is, well, what's their average, right? What's the mean? So even though the mean for both classes is basically the same, okay, so we've got the same mean, right? They both averaged out at 78. Now, maybe slight differences in, yeah, basically the same. I think they are the same. The results of the two groups are quite different, right? They have the same average, right? Now, I really shouldn't be using the word average, right? Because we've got 3 averages, right? There's the mean, the median, and the mode. So usually when people say average, they're talking about the mean, right? But then we should be just specific and say we're talking about the mean. So describe the scores in Group B as compared to Group A. So if you look up above, you see Group B scores. What do you say about them?
They're lower than Group A.
Well, lower or
Oh, that's better.
yeah, they're closer to the mean, right? So if we look in Group A, so we got a 94, right? That's really high, right? It's 16. If you look at the deviation, that's plus 16. We got a 56. That's minus 22, right? And the biggest variation we have in Group B is 5, right? Like the difference between the mean and the highest mark is 5. So the Group A data is more spread out from the mean. Group A data is more spread out. From the mean. And the Group B data is closer together. Both closer together and closer to the mean. And closer to the mean. Okay, and so standard deviation is a way of describing that, right? It's a way of putting a number to it, and we can say, oh, look, that number, that standard deviation for Group A, which is 14.27, and the standard deviation for Group B is 3.4, that's a much smaller number. The mean of the scores of Group C is 78, and the scores are shown below. How do you think the standard deviation of Group C would compare to Group A and B? So, same mean. What's our standard deviation going to be compared to A and B?
Probably closer than both of them.
Yeah, smaller, right? Because those numbers are all, like, there's really not much, right? What's the biggest deviation? Like 2, right? 76 is 2 units away from the mean. So, we could do this using our calculator, right? So I'm going to pull up the old school TI-83. Sorry. Come on, give me the calculator. Okay, so turn it on, unless this thing won't turn on. Alright. It's too old, it doesn't work. Okay, so I changed calculators, it's still not working on the board. So we go to Stat, and number 1 is Edit, so you can hit Enter. If you've still got something in there, remember, second function plus takes you to the memory. Number 4 is clear all lists. Clear all lists, okay? So if you go on L1, there's something there, go second plus 4, enter, clear, and enter again. Or no, 4 and then enter, that'll clear all the lists. Okay, so we're just going to enter those 5 numbers from group C, which were 79, 78, 76, 78, and 79. Okay, so I got a group size of 5. Now remember, we use L2 when we get a frequency table, right, which tells us the mark 78 occurred this many times. We don't have a frequency table. There's only 5 marks here, right? That's always looking at the n equals, right, the number of values entered. So if you're using a frequency table, you know you're doing 100 values. Make sure you see 100 down there for n, right, that you actually did the L1, L2. Okay, so then we go to Stat. And over to Calc. And one variable statistics, so hit Enter. And if you're using this, just leave the frequency list blank on this menu. And on the TI-83, just go 1 bar stats, enter, okay? It'll default to L1 by itself, right? The time we have to do something different, if we have a frequency distribution, you're going to go L1, comma, L2. All right, and this tells us, so we've got the mean. The mean is 78, right? Which they told us anyways. You notice how it adds up the x's for you, right? Because it does the sum of them. And so the mean is just the sum divided by 5, right? 390 divided by 5. We don't care about those. The sum of the squares, we don't care about those. This is what we care about, this sigma x, okay? That's the standard deviation, right? Population standard deviation, that's the one we use, okay? So we're interested in usually like 2 stats here, right? We're interested in the mean, we're interested in the standard deviation.
What's that sign?
What?
I can't see anything.
Well, you're with Ryan.
Oh, okay, okay.
You can look on your calculator.
I couldn't match them, but I got it.
Okay, now other stuff we're interested in are also the max, right? We see the range is 79 minus 76, gives us the median is 78, right? And the number is 5, right? Those are the stats that we're interested in. Today, really, we're just interested in the population standard deviation. Okay, which was 1.095, so 1.10 if I'm rounding to 2 decimal places. Okay, so 1.10. The group A standard deviation was 14.27. And the group B standard deviation was 3.4. And the group C is 1.10. So was your prediction in question whatever correct, right? And yeah, so the prediction that we had was that this would be a lower standard deviation because the numbers look closer to the mean, right? And remember, the standard deviation is a measure of how spread out the data is. Okay, and if whatever field you go into, you do any statistics, anything with a normal, just you're going to run into standard deviation over and over again. Part C, examples involving standard deviation. The field goal percent for 3 players for the last 10 games in which they played is shown in the table below. So what sport has field goals? Field goals. It's actually basketball. I know, right? I mean, they never call it that, but that's what it is. It's a field goal.
It says on stars, yeah.
Yeah. Yeah, they actually call it a field goal, right? That's a technical name, but nobody calls it, baskets or hoops, but it's a field goal. Okay? Yeah, I mean, field goal, what, I kicked the ball through the upright. And so a number of sports have field goals, but anyways, so we got Anna, Patrice, and Morgan. We need to calculate their statistics, right? So the mean and the standard deviation. So what I'm going to do is just pause this, right? And we'll just go through and we'll calculate them. So do all three. All right, so as if by magic these numbers have appeared, right? At least if you're watching the video, it's as if by magic. So we've got Anna's mean. So the means are, well, these two are relatively close. Morgan's a little bit higher, but her standard deviation is a lot higher, indicating that, yeah, she has a higher mean, but she's less consistent. So which player has the most consistency? Patrice. How does the standard deviation verify your answer? Okay, so Patrice is the most consistent. She has the lowest standard deviation. Yes. Oh, you messed up, man. What can I say? If you've got all the numbers in L1, L2, L3, just go through the numbers and check. One of your numbers has to be L1. Different answer, Morgan? Morgan. Oh, okay. What, like 9.0 or?
9.0 and the mean was 35.8.
Yeah, I agree.
35.8?
Yes.
He's right. We got
35.8?
Yes.
Oh, well, okay.
Yeah.
So 35.8 and 9.0. I bow to the will of the majority. I'm just copying up this, which, yeah, okay. See, now that's the thing that we can do as a class when we do this, right? That's why I don't really worry too much about, if I get it wrong, you guys will have a different answer and say something. On a test, go back and check, once you've entered these numbers, just go back through the list and check the numbers, right? It won't take long. You won't be doing more than, maybe you do 10 or 12 numbers, but it's easy to slip while you're entering a number. And if you do, all your values are off, right? So just go back through it and check the numbers.
There we go. Thank you.
Welcome. Okay. Forward. The bowling scores for John and Janine are shown in the table below. Determine the mean and standard deviation for the bowling scores for John and Janine. Okay, now. You will notice that we have bowling scores of 101 to 105, right? So that's like, well, how do we handle this, right? Because it's not a number, right? It's a range that's represented. So what we're going to put in L1 is the middle of each of these ranges, right? So we're going to say, we know that John had 2 games in which he scored between 101 and 105. And the number we're going to use to represent that is the middle of 101 and 105, which is 103. Okay? So this will be 103. Middle of 106 and 110, 108. We're basically just adding 5 each time. You see each of these guys go up by 5, and so do each of these guys. So then the middle is just going to go up by 5. So 113, 118, 123, 128, 133, 138, 143, 148, 153, 158. So you could put those in L1. You could put John's in L2, and you could put Janine's in L3. Okay. Now this is a frequency table, right? So if you're going to put John's in L2 and Janine's in L3, you're going to run one var stats L1, L2 for John, and then run one var stats L1, L3 for Janine. right? Or on this fancy calculator here, you would put in L1 and then the frequency list you'd put L2 or L3, right? And you would change it around. Okay? Or you could just enter this in L1, these in L2, do your 1-var stats L1, L2, then go and enter these in L2 over top, and then do 1-var stats L1, L2. Okay? If it were me, I'd enter these in L2 and these in L3, right? Because you can check them and make sure. And if you're trying to enter the L3s on top, because you don't want to clear your list, you'd have to re-enter these guys, right? So the last thing I want to do is enter L1 twice if I go and clear my list, right? So you're going to do, for John, 1-var stats L1, comma L2, and for Janine, 1-var stats L1, L3. Okay, and I will pause this while you. What is John's mean? Rounded to 1 decimal.
I'm sure you know what that is.
Okay, what is Janine's mean?
133.5.
So without looking at anything else, who's the better bowler? Janine. Okay, what is John's standard deviation?
12.7.
What is Janine's standard deviation?
8.5.
Okay, so we know that Janine had the highest average score, right? So Janine. And which person is the most consistent? John. Okay, so that's what standard deviation is, right? If you're just measuring one person on a set of things, it would be their consistency. So you could do this for basketball players, you could do this for golfers. You know, and you could see, okay, so maybe somebody has, so Janine has the higher average, but she's not as consistent, right? I mean, she's going to score low, she'll score high more often than John does, but she'll also score low more often than John does, right? On average, she gets the higher score, right? But in consistency, so if you're choosing a team, if you're the coach or something, you got to choose a team. You may have to decide between, yeah, this player has some hot streaks and they can really score high a bunch of times, but this player is more consistent. Yeah.
It's like the deviation expectation fee.
You could kind of think of it that way. It's consistency, right? It's like how consistent. So the lower the number, the more consistent, right? It just means you're closer to your average more often. Okay. So with the class scores, we would say everybody in Class C is. They're really pretty much all the same, right? You can't choose between any of the students there. Class A, well, we got somebody, wow, 96, right? Like, scores really high. But we also got somebody that scores really low. So in comparing a single person like this, it's the person's consistency. In comparing a class or a group, then it's how is this group as compared. So if you look provincially, you know, you guys are going to write the Math 30-2 diploma exam, right? And there will be a statistic for the province. You can look up statistics online. There will be an average, and then there will be a standard deviation rate. And it's not going to be wildly different year to year because we're talking thousands of students, right? So when you get thousands, things tend to be a little more consistent, right? But if they look at it and they say, wow, standard deviation is high this year, well, then either we have a group of students that's really consistent, or the test is geared more to one group, right? So that, you know, some people are finding it a lot easier scoring high, some people are finding it a lot harder scoring low. So it's a measure of consistency, or it's variation from the mean, right? Deviation from the mean. Following histogram displays the number of points a particular basketball player scored per game in the first 100 games of his career in the NBA. So I think we did this graph, right? Yeah. So this information is being presented to us as a histogram. We can translate that into a frequency chart, right? And find the mean points and the standard deviation rounded to the nearest 10th. So you can either flip back, right? I think we flip back. I think it's the same graph, right? So if we flip back, or actually I'll flip back and I'll give you the numbers. Okay, what were they? 1, 2, 1. So 1, 2, 1, 4, 9, 19, 8, no, 11, sorry. 11, 12, 2. Okay, so what you would enter in your calculator, right? L1 is going to be 6, 7, 8, 9, 10, 11, 12, right? These are your L1s, points per game. And these guys here, that's your L2. Okay, so you're going to want to go second, mem, 4, clear all this, right? We're done with the other stuff. And when you run your 1 var stats, just make sure you run 1 var stats L1 comma L2, or 1 var stats L1 is the whatever it calls it, and L2 is the frequency list. Okay, and make sure that your n is equal to 100. It's not work, Laura. It's practice.
Practice.
That's how you're gonna get good at it. You're gonna practice.
Talk about practice, how it matters.
What were you doing last night before you went to the store? You were practicing, right?
So we talked about practice. She needs to practice his shot.
None of you guys expect to get good. So we're gonna run 1 var stats L1 comma L2, right? Or L1, frequency list is L2. You should see n equals 100, right? That's your check. Make sure, right? Because we know these are the first 100 games of the guy's career or whatever. So you should see an n equals 100. Okay, so what's the mean? 2 decimals to 2 decimals. What do you got? 12.56. 12.56 what? Points per game, right? So on average, 12.56 points per game, PPG. And the standard deviation, okay? We use that sigma, or the best approximation of a sigma that you can make. And what is that? 2.40. It's also in points per game. Okay? Now, standard deviation is going to mean a lot more in a few days, right? Because we're going to relate it to distributions and graphs, like a distribution like this, and we'll say, what does that mean, that 2.40 points per game? And there's an actual pretty good meaning to that. Okay? All right, we got the soccer. So we got 4 soccer teams, the greenies, the meanies, whatever. Okay. I figure that you're, whoops. Yeah. All right, I'm gonna pause this while we wait. Okay, so determine the standard deviation. Really should say state, right? Because we don't want you to ever work these out by hand. Okay, so it should just be state. So the greenies, 2 goals. There is a measurement, right? If there is a label on the x-axis, points per game, goals, whatever, that's the units the standard deviation is in. It's in, if it's percentages, like class scored percent, it would be, a standard deviation would be so much percent, right? It's the same units as the mean. So mean and standard deviation have the same units. And okay, which team has the lowest standard deviation? The Reds. Which team is most consistent? The Reds. Okay, so if you look at the distribution here, you can see greenies are pretty spread out, right? Like as far as range goes, they've got the largest range. Stars, no, it's really spread, right? Like they're not consistent at all, really. Okay, the Taz are more consistent.
They get 2 goals every game.
Okay, so if you look at the Stars, you see no, they don't get 2 goals per game. Their standard deviation is 2. Right. Oh yeah, and they do get 2 goals per game. The greenies are the most spread out, right? Like they're either really good or they're really bad, right? Like they either get, like no goals a bunch of times and 8 goals a bunch of times. Reds are the most consistent, right? Their mean lies in here. They're the closest to the mean. Okay? The Taz are second most consistent, right? Because they're grouped. So which team has the highest standard deviation? Greenies. So what does that mean? They are the least consistent. So standard deviation could be used in these goals thing. It could be used in the life of a battery, right? So Duracell makes batteries. They pull batteries off the line. They check them. How long do they last? The more consistent the batteries, the lower the standard deviation, right? They'll just be consistent. Whereas you get some cheap knockoff brand battery that ships with your device, you know, some of them might last a really long time, but some of them won't last that long at all, right? And so they're not as consistent. The mean, okay, so totally separate question, right? Just multiple choice question. Okay. The mean of 10 scores is 12.5, and the standard deviation is 2.6. If 5 is added to each score, what's going to happen to the standard deviation? Will it increase, will it decrease, or will it remain the same?
Well, it would be the same probably, because it's it wouldn't.
So remember, standard deviation describes the spread of the data. Okay, so we've got this data here. We add 5 to all the scores. It'll remain the same, right? Because we haven't changed the distribution, right? We've simply slid it over. It'd be like saying, so if these guys actually score one more goal per game than that, we would just take this and move it over one. But the shape doesn't change, right? And the shape is what gives us the standard deviation. If it's more spread out, it's a large standard deviation. If it's tighter together, it's a small standard deviation. If we change by adding a number to everything, we've changed the mean. The mean will increase by 5 in this scenario, right? The mean will go up by 5. Standard deviation will remain the same. Now, the way that we would ask that on a for real, because you never get ABC as a question, right? It said, if this happened, then the mean would, and the standard deviation would, right? So we'd say, like, the mean would increase, standard deviation increase, decrease, increase, remain the same, decrease, remain the same. Okay? And, you know, that's how we ask as a multiple choice question. Anytime you're working through questions, always ask yourself, how would they ask this as a multiple choice question? Or would they ask this as numerical response? Okay, so in general, a blank standard deviation indicates blank consistency within the data. Okay, let's put in a lower standard deviation indicates what? Higher consistency, or let's say greater consistency. So the lower the standard deviation, the greater the consistency. And you could also say a higher standard deviation indicates a lower consistency. Right? Not as consistent.